Hello, let us start with a word problem. A popcorn and two colas at a movie theater cost $18. A popcorn and four colas at a movie theater cost $26. How much are the popcorn and cola each? Let's take a look at this problem. First of all, what is the problem talking about? Well, it's talking about the price of cola and popcorn at a movie theater. Okay, let's go through and identify the numbers. There's a few that leap out. $18, $26. But we've also got a few other things in here that might not leap out as much. What other numbers do we see? Well, I've got two colas. I've got a popcorn there. That's really one when we see that A there, right? Same thing down here. And of course, we've got four colas down here. What I can do is I can think about these in terms of equations. And I can't put them all into one equation, but I certainly can put them into two. I really need to identify how many variables that I've got. And in this case, I've got two unknown variables. I've got really the price of popcorn, because I don't know that. That's what I need to find, right? And the price of, what's the other thing that I'm supposed to find? The price of cola. To substitute for these, I can use a variable. And I'm going to say P is my price of popcorn, and C is the price of cola. By using these, I'm able to set up an equation that P plus 2C, remember I had one popcorn and two colas, would give me 18. And this makes sense because I have the price of one popcorn, because really remember, if you don't see a coefficient there, that means that I've got just one, plus 2 times the price of one cola, so the price of two colas would be $18. Similarly, in the second statement, the price of one popcorn plus 4 times the price of one cola, so 4 colas, would cost $26. Okay? Simple enough, but what do I do next? Well, let's flip these. We can do that. We can look at them in a different order. I just want to look at that second equation. I want to put that on top for right now. And we're going to see why in a moment. But I'm not changing any values. I'm just reordering things. And that's a very handy tool to have handy when you are working with things in mathematics, changing the order from time to time. As long as there's nothing against that, that's okay. Now, here's where we get a little bit more detailed. What I want to do is I want to basically add these two equations together. But in order to do so, before I do that, I'm going to make the whole bottom equation, everything there, negative. Why? Let me show you my goal. I've got the price of popcorn and cola. I've got two variables in there. There's no way that just with this one equation on top that I could figure out the price of popcorn or the price of cola. I'm always going to have to deal with the other one. However, if I combine the two in such a way that I can eliminate the price of popcorn, then I'm just going to be left with the price of cola and an integer, or a real number. Real number, but in this case they do happen to be integers. Then I've just got the price of cola times some number would give me some real number. The popcorn would be gone, and then I can solve. So let's do that. But first, in order to, again, to make this happen, I need to apply this negative sign here to the whole equation. So it's going to distribute the negative to the p, it will distribute to the 4c, it will distribute all the way here to the 18. Think of it like the distributive property. We're applying a -1 to both sides. Quite technically, we probably would want to say that you're multiplying both sides by -1. But if you think about it in the terms of I'm making everything negative, that might be an easier way to remember it. But the process, we're actually multiplying both sides of the equation by -1 to make them negative. What does that make this look like? Well, after I distribute, the p becomes a negative p, the 2c becomes a negative 2c, and the 18 becomes a negative 18. Okay? Now, I can add them together. I'm just going to add straight down. P minus p would give me 0p. So technically, again, you have a 1 coefficient in front of these, right? So p is really out of the picture at this point. 4c minus 2c. That leaves me with 2c. And 26 minus 18. That leaves me with 8. So after combining both of these, I'm left with 2c, because 0 times p, that would just be 0, so that we can get rid of that 0 there. 2c equals 8. To solve for c, divide both sides by 2. C equals 4. That's it. So what is this telling me? C equals 4. Basically, the price of cola is $4, which is why I rarely get cola when I go to the movie theater. It's really expensive, at least in the United States. It's just the model of they use to make profit in movie theaters, which is what they do. 2c equals 8. That's the end result. Now we're going to plug in to solve for the price of popcorn. I know that c is equal to 4. So p plus, if we know that c is equal to 4, 2 times 4 will give me 18. Simplify. P plus 8 equals 18. We want p by itself. So I'm left with p equals 10. So the price of popcorn is $10. Another reason why I don't get a lot of popcorn at the movie theater. So, using these processes, we've gotten the price of popcorn, the price of cola. It should work, and it certainly works in this equation with the 2 colas. But does it work in the other one? That's how we can check and make sure that it works. So what we got so far was that P is equal to 10 and C was equal to 4. The price of popcorn is $10. The price of cola is $4. Let's see if it works. Substitute in 10 for P. 10 plus 4 times 4 for C would be 26. Let's see if this is true. If it is true, then we're set. 10 plus, what's 4 times 4? Equals 26. 10 plus 26 is 26. 26 equals 26. Check. That is true. And it works. Our solution set then would be over here. The price of popcorn is $10. and colas are $4 each. That's it. That's it. We can do that by, again, we multiplied one whole equation that we had here out of the two. Going back up to here for a moment, we made this whole thing negative so that I could really eliminate the p. Get that out of there. And this is called the elimination method. There's many ways, well, many. There's a few ways to solve these. But this is the elimination method of solving linear systems of linear equations, because you're eliminating one of the variables. So what I would like you to do is try one of these so that we can talk about that. Similar situation, but a little bit different. A cola and a donut, which I'm sure is a lovely combination of flavors right there. Yeah, picture that for a moment. A cola and a donut costs $3.50. A cola and 3 donuts cost $5.50. How much is the cola and, whoop, my apologies, not candy bar, donut. When I first wrote this, I realized that I had lots of things that began with whoa. Just in case, so if the spoilers are coming up in one moment, I'll set up the equation for you. But try this and then on your notebook, and we'll talk about this tomorrow, okay? There we go, spoiler alert. You can use that as the basis of your setup. Find the price of each, all right? Have fun with it. Have a great day.